This is Breaking Down Security for February 28th, 2015. I'm Brian Brake. Hello, everybody. Welcome back. Last couple weeks was been without Mr. Boettcher, but I'm proud to say and glad to say that he is back with us today. Hello, Mr. Boettcher. How are you doing today?
Yes, I'm doing good.
Excellent. Where were you? You were on vacation or something?
No.
Oh, okay.
Working.
All right. Well, you have been working. You got us. You've been out, but you've been helping us get our next interview, which I'm pretty pleased with. We have Jeff and Strad. Sorry, I did it again. I told myself I wouldn't. Strad, who are developers and maintainers of I2P, the anonymous network, an anonymizing network, very similar to Tor. And welcome, gentlemen, to the show. Welcome to Breaking Down Security.
Welcome.
Hello.
Thanks.
Yeah. So I guess we'll start with Strad. Well, I wanted to find out, since we're not using names here, how you got involved with I2P and maybe a little bit generically what you do for a living.
I can honestly say I can't remember how I stumbled on I2P.
Really?
Like yeah, I've been around for about 4 years now, and yeah, I was just trawling the internet at some point, finding interesting places on, in the back corners of the web, and I believe I came around onto Tor first, and then it was just playing through, hopping through IRC channels and finding things, and stumbled upon. Must have been the one of the freenet relays to IRC2P, which is the IRC network inside I2P. And got chatting to some of the guys there, and liked the crowd and stuck around.
Very cool. Okay. So you have a day job, I assume, or you work at in security, or you just do something totally different, like are you an account manager or something, or a sales weasel or something like that?
I do something completely different. We'll say for now it's more in academia, but nothing at all to do with security research. It's just something I do for fun.
Cool. Well, Clark Kent was a reporter, and then, he became Superman. So, there's two totally different things. So how about you, Jeff? How did you get started with I2P, and maybe generically give us an idea of if you are, a sales weasel or something, or if you work in security?
For me, it's pretty much the same story how I stumbled upon I2P. I don't quite remember where I found the link, and I don't really remember how I found it, but I also stuck around because it seemed like a really interesting place to be because of the anonymity aspects of it. And right now I'm currently out of college and looking for work.
That makes it kind of hard being, anonymous and looking for work. It's kind of,
Well, yeah.
Yeah. I had actually not ever heard of I2P before I started researching our Tor podcast a couple of months ago, because I was trying to figure out if there were alternatives to Tor, because when I used Tails, which is the Linux distro of Tor, I found it horribly, horribly slow. And I was like, well, there's got to be a better, network. And then I found I2P, and I found a couple of others that are probably even more of a niche type of internal type network. And then I heard that Mega Kim.com is creating like a Mega Net or something that is kind of
which no one knows anything about yet, really.
Yeah, it seems like a lot of vaporware.
We'll see what happens. I mean, his general description of it tends to make it sound very much like what I2P is. So we'll see.
Okay. Well, that's a good segue. So, can you describe a little bit of what I2P is, and why somebody should use it over, say, Freenet or Tor?
Um, I2P is effectively an internet on top of the internet. It's a medium on which you can communicate anonymously with no trusted third party infrastructure, no uh, central parties that need to be always online for you to be able to send your packets around. Um,
So it sounds kind of like Nutella, right? Like my sister and I used to use BearShare so we could like download royalty-free music and stuff.
It's basically the same idea as a Tor hidden service. So that's a sort of good mental jumping off point for understanding I2P. Basically, if you think of the regular internet, you have computers with IP addresses, and like when you access a website, your computer's connects from its IP address to the server's IP address and sends a, hey, get the homepage, please give it to me, thank you. And the server, assuming that it thinks you're a good client, will go, hey, here's the website for you. I2P generalizes that to an anonymous network system. So instead of having an IP address that makes a request for a website, you have what's called an I2P destination. So tying into what Meganet is saying, they're talking about non-I2P based networks. In I2P, sorry, non-IP based networks. In I2P's case, that is this cryptographic destination. And so as far as the network is concerned, they just see this destination making a connection to their service. Or in, say, torrenting over I2P, you have you identify peers by their destination. Now, of course, the destination is actually just some other computer in the network, and so you effectively, when you want to send a packet to them, you send it to that computer, and that computer then routes it through a series of hopping through a tunnel to get so that the packet will actually get to the destination of the router that's actually hosting that peer. Okay. So in that sense, from a high level, it's similar to the way that Tor's circuits work, where you have a packet that a Tor client sends through the network to a server. It hops through a series of nodes.
Okay, and that's it's affectionately known as garlic routing, or is that
Garlic routing is sort of a slight build-up from that. So just as a quick recap, onion routing is this tunneling process where you have effectively a packet sent through a series of encrypted links. So you have end-to-end encryption, and then outside that you have encryption for each hop. So that's where the onion comes from the layers. Garlic routing is effectively a step beyond that, where you have the encryption between each hop. Inside that, you have the encryption end-to-end. And then once the packet gets to the end, inside that, you then can have a bunch of different messages. So one example would be, I send a message to a server, and inside that message, there is my request for a web page, but there's also a request saying, hey, could you just flick a packet back and just let me know that that this request has actually gone through. Or you could create more complex routing structures where one of the messages inside your packet is actually a message to be sent to another destination entirely.
Is that called a clove, where you have a bundle of messages, and some might be from you, but some might be from someone else that you're just forwarding?
In theory, yes.
Okay.
So there's some of these ones are effectively they're networking strategies that can be used. They generally aren't being used yet, but the network does support those sort of more esoteric routing strategies. So if an application wanted to include these extra forwarding techniques and things to effectively throw people off the scent, they could do so.
So it sounds like I2P is a lot like the postal service, where you have truck full of letters, some designed for post office A and some designed for post office B. So A takes the truck, with all the letters in it to the one post office. It takes 10% of the letters which have a unique identifier like an address, and the rest of those get shunted off from A to B, where B picks off theirs, and is that how it works? Kind of in a group of post offices, or did I oversimplify that too much?
A little bit, I think, because if you're using that analogy, you've effectively got two levels of post office, because the garlic routing bit is an end-to-end technique. Mm-hmm. So it's the garlic clove is unpacked at one end of the tunnel, at the end of the tunnel. So you take the clove, put it into a tunnel, and then it comes out the other end and gets split up, and then you can process it from there.
All right.
Whereas the bit that then has already been anonymized, but then you can do more with it. The anonymizing process itself is still more akin to onion routing, really.
Okay. Why create I2P if Tor? Was there things in Tor that you didn't like, or that the original creators of I2P, from what I understand, the original guy was working on it and then just kind of said, I don't want to do this anymore, and gave up the source. Is there a reason that he started I2P? Was he not happy with Tor, or did he just think he could do a better job?
Well, Tor actually, I believe, started a bit after I2P was started.
Really?
Okay. Yes.
Yeah.
So,
right on.
So the original Onion router, I think, was about 2002, 2003. Tor, of course, was the second generation of that. It got started about 2003, 2004, which was right about when I2P was started as well. And of course, neither Jeff nor I were actually around at the beginning. The one who has the advantage of that is our main dev, ZZZ, who's been around basically 10 years now.
Wow.
He came on pretty soon after it started, just stumbled across it. But no, the original idea was to it emerged out of Freenet, actually. So have you heard much of Freenet? Have you done a podcast on it yet, or?
No, we haven't done anything on Freenet yet. That was one of the other alternatives that I saw that I was going to investigate, but you guys were more approachable and actually got a hold of you first. So first to market, as it were.
Well, in essence, what happened, at least from reading the various meeting logs and the history that I've seen, Freenet is effectively a shared data store, in a sense. You cache data for other nodes, and then when other nodes request it, you can get it back. So yeah, distributed data store, similar but not really quite the same as Tahoe Labs, the least authority file service system. Sorry, they changed it. But as developers from there realized that it would be beneficial to have a more general network layer for anonymizing transport, in a sense. And so originally started out as IIP, was it, or IIT? Like effectively starting as an invisible IIP, an invisible internet protocol. And then the developers realized that actually this really should be its own project. So they then pulled it out and started I2P on its own as a sort of a reboot separate from Freenet. Incidentally, they started it out in C or C++, I believe. Actually got as far as implementing their own memory management stuff, which actually ended up in some game, I seem to recall. And then one of the devs decided actually Java would be a better thing to get it going in, and started basically re-implementing the early work they'd done in that, and that one ended up taking off. So it's not really, it doesn't really make sense to say it was developed because we didn't like something about Tor. At the time, they really had different perspectives. Tor was focused on helping hide the identity of clients, whereas I2P was about creating an anonymous overlay network so that you could develop any application you wanted and give it anonymizing properties.
Okay.
So really, if you want to go to regular websites, you would use Tor, I2P.
Yes.
You wouldn't want to do that.
Really the way to do that would be for the website you want to go to set up a presence inside I2P.
Yeah.
Right. Or to use someone's exit node, right, within I2P.
Yeah.
Which I don't know how many there are, but I wouldn't want to run one.
There's like 2, and
yeah,
yeah, they're also they also are on the IP blocks of exit nodes for Tor. So there's not really any.
So why? Yeah, I see. Yeah. I see where you're going.
It sounds like that I2P is more extensible than Tor is. You would be able to add additional features and functionality on top of it, whereas Tor is just, make sure that people can get to pages and share information.
Right. I2P is more of a developer framework and accompanying network than it is pipes like Tor is.
Mm-hmm.
I have spent time looking at what Tor provides and what I2P provides from a developer's point of view, and I found that Tor does provide some APIs for applications to use hidden services and to provide a platform to develop applications for Tor. I2P has something like that, and it has had that from basically the first day going on, and it is probably better than anything I've seen Tor provide so far.
Cool.
Yeah, on the flip side, Tor's been focused on you allowing users to just reach something, which is why the classic distinction is Tor basically only focuses on Tor browser now, whereas I2P basically can do everything except have its own browser, because we just don't have enough people to maintain it.
Sure.
Which sort of exhibits sort of the difference in focus, and also explains to some extent why Tor has become so much more popular than I2P, even though they've existed for the same amount of time, because users could just install this thing and access the websites they wanted to, because they just had to do one thing and then nothing else had to be done. Whereas I2P, there's a lot more cogs that have to fit together in order to, you're effectively starting the internet from scratch, in a sense.
Yeah. Okay, so let's talk about that. So with Tor, you have the Tails bundle. They have a fancy, ISO you can download. And with I2P, you said there are a lot more cogs to understand. Do you think that that's the barrier for why your I2P isn't more adopted, or is that something that you guys are priding yourselves on, that really you've got to work to get your privacy and security in place? And is it a thing where if you don't set I2P up correctly, you're pretty much going to be, you're not going to be anonymous from the get-go, or are there various levels of, anonymization and privacy that you can achieve with just a basic setup?
So it's said that I2P allows users to be in control of their own anonymity, reliability, bandwidth usage, latency. Maybe you could explain how that's possible.
The I2P router just has it's a router. So effectively, we have a console that you can go in, and there's a lot of things you can tweak as far as that. Which, in my opinion, is really a double-edged sword, because we have a lot of things you can tweak and work on that. But that said, 99% of our user base, at a blind guess, probably doesn't tweak any of it. So
are you secure by default if you were just to set up a default I2P, or is there additional things that you need to do?
The default settings we use, we try and choose so that if no one modifies things, they will have a level of anonymity. But there's a disconnect here that I think we need to discuss. The I2P is a transport level anonymizer. So think of it like a crypto pigeon. You give a message to the crypto pigeon, and it flies off and it gets it to where it needs to be in an anonymous fashion. That's fine. But if you give your social security number to that crypto pigeon, it can't do anything about it. The other person will know who you are.
Sure.
So, stepping back into a computer sense, effectively, I2P is the transport layer, but the applications that you're using with it still need to be wary of, need to understand the fact that they're trying to be anonymous. And this is where Tor does very well with their browser, because they have taken an already reasonable browser and added a whole heap of different privacy patches to really lock it down. Whereas, of course, I2P, we don't provide that, although you can use I2P with it. Because for a general user who just comes along and wants to use it to access a website inside I2P, the way we do it is just you put into your web browser's proxy settings, you type in, say, localhost 4444 to access, to tell it to route all its traffic through there. But that doesn't change the fact that the browser itself could still be de-anonymizing you, which is why we generally recommend actually using the Tor browser and just reconfiguring it to go through I2P as as the general browser. And in fact, another developer has recently started on the Abscond browser, which effectively is a build of the Tor browser, but without Tor and with I2P instead, trying to sort of develop the same sort of system, just to make it easier for users to actually get started there.
Yeah, you don't want to be running, say, Firefox and then have Firefox be going and looking at mozilla.org to check for updates.
Yeah, and I will probably get to more security concerns and things in a bit.
Okay. So you have to have you really have to have an accounting of the programs you're running on your box, because if you have anything that runs as a service, or your IRC client has to be shut down for looking for automatic updates, or going out to look at specific say EFnet, or if it's going, hey, I'm connecting from this IP address, then you're pretty much losing any anonymity or security or privacy you had in the first place.
Yeah.
So how many users does I2P have currently?
This is a tricky thing to figure out, as you noted, talking to us beforehand. Stats.I2P, that's a service that you run by ZZZ, who to basically measure different statistics on the network, doesn't really say that anymore. It used to try and make an estimate. The problem we have is I2P, as Jeff alluded to earlier, is a distributed, decentralized network. So there's no one place to go to measure, to look at the statistics of the network, which in a sense is a good thing, but it also makes estimating these sort of things tricky. Based on the few central things that we do measure, we estimate at the moment about 50,000 routers in the network.
That's
just as a rough estimate.
Okay. So does I2P have a central index server? I mean, how do you know how to connect to someone on the network?
There's two levels to this. The first, of course, when you install I2P and start it running, it doesn't know any other routers in the network. So what we have is, it's called a reseed server. So we have a bunch of volunteers around the world who operate these servers, which basically serve up the information of other routers in the network.
All right.
So your router, when it starts up for the first time, or if for some reason it gets disconnected from all its nodes and can't connect to any, it will connect to these reseed servers and download what are called reseed bundles. And these contain router information, which is the router info of a bunch of different other peers in the network. Once it has those, it can then connect to those peers and integrate into the network. Now, reseeding is only used for initially connecting to the network. Once you're in the network, you participate in what's called the NetDB, the network database. And this is effectively a DHT, distributed hash table, which stores these router infos. So it is, in Tor, you have the directory authorities. So you have the relays publish their information to the directory authorities, and the directory authorities use that to create a consensus, which contains every relay known to Tor, which I think at the moment is about 5,000 relays. And then clients download that entire bundle, bits of that bundle, and can connect directly to the relays. In I2P's case, we have what are called flood fill servers, which are the primary operators of the network database. So when your router connects to the network and becomes integrated, it, of course, wants to publish its information so other routers can connect to it, so it can integrate in. And so it will contact a flood fill and go, hey, here's my router info. Could you please publish this? And so the flood fill will take that router info and replicate it to the closest 8 flood fills that it knows to itself, around the hash of the router info. Basically, it's a DHT thing which allows you to find it later.
Okay, so it sounds a lot like BitTorrent then, where
in a sense,
you start a torrent and it has to go out to the DHT servers and pulls down all the users who have pieces of the file that you're trying to download.
Yeah, but it's not quite like a straight DHT, because a DHT, every node in the network participates in it.
Yeah.
I2P, they do to a sense, but the flood fills are there to effectively supercharge that. So they will actively push out network information to other flood fills to ensure that it is well accessible.
Okay.
And so we have we mid last year we upped it so that we'd have as many flood fills as we felt would actually run it. And we have probably a couple of thousand flood fills now out of the 50,000 nodes.
Cool.
So which are the ones running, like I said, running the network database.
Okay. Is that dynamic? You choose based on uptime and bandwidth and all that?
Yeah.
Okay.
Here's this is one particular difference between Tor and I2P. Tor clients rely on the consensus. So you have those 9 central directory servers, authorities, which basically decide every hour, this is what the network is. And this is what we believe is, these are the various bandwidths and things that have been published. This is what we believe is true. I2P, as I said, is decentralized, distributed, and we do not trust any other server by default. Well, in a sense, the only ones we really would have a level of trust in would be the reseeds. Everything else is by default untrusted. So the implication of this is that every router in the network makes its own decisions based on the information available. So I might talk to a flood fill and get a bunch of routers and say, okay, the flood fill has told me that these routers are, a set of routers to use in the network. But I'm not going to trust what that router says about them. I'm actually going to connect to them and make my own measurements. I'm going to measure the bandwidth, throughput. I'm going to measure how often a tunnel that I build through that router fails, how often that tunnel is dropping packets. And basically, my router collects a bunch of statistics on every peer it knows. And in that sense, builds up a list of peers that it trusts. Mm-hmm. And those peers are then the ones that it uses for building the client tunnels that it uses for anonymity.
Okay. Trusting for throughput and availability?
Yeah, basically.
Okay.
Yeah.
So let me ask you a question. So let's say I'm in St. Louis and I start up my I2P router. It's going to connect and send my router when it advertises out to 8 other flood fill routers in the geographic region.
Not the geographic region. It's what it does, and this is a regular DHT thing that's used. When you want to look up something in a DHT, you look it up by effectively a key. In our case, the key is a hash of the router info. Okay. And so what your router does is of the flood fills it knows, it may know 10, 15. If you're a high bandwidth router, it may know 100, 500. It picks the flood fill whose own router identity hash is closest to, via an X or a metric, basically just a particular metric. Its hash is closest to the hash of your router info, and it sends it to that router. And then that flood fill then sends it to the 8 ones that it thinks are closest. So what that then means is when some other router goes, oh, I need to find your particular router's info, it sends a DHT request for that hash, and the flood fills will then iterate through and work and find the flood fill that has the information that is closest to where that information should be, and it will very likely have the router info that your router is looking for.
Okay. So, and before I get started, I know the irony is not lost on me that we're using Skype for anonymization. Talking about anonymization, I know that you've gone through a few hurdles tonight just to get Skype running, and I appreciate that. Oddly enough, we didn't have any other idea other than maybe Hangout that we could use. So, with regard to applications and functions, I've set up I2P, and I find that it's just as slow as Tor with regard to speed or look. Mr. Boettcher said he started a hidden service site that he sent me the what appears to be a rather long hash, but I know it's not. But I couldn't get to it. I don't know if it's because he didn't set it up properly or what. What kind of can you actually do work on the I2P network, or is this more like hey, I just want to make sure that I can check my email or communicate with people without being monitored?
The first thing I'll say, of course, is that there's going to be a trade-off always between anonymity and speed, because the more hops you have to go through, the slower you're going to be. Just purely because, effectively, you are sending a packet through 3 other computers. And in fact, when you account for the hops in your tunnels, the hops in their tunnels, and the hops going backwards, there's about potentially 12 different routers involved in a connection between a client and a server, or between 2 peers. So your speed, of course, is going to be limited to the slowest of those 12 peers.
Okay.
Right.
And 6 of those peers... Yeah, 6 of those peers you choose, 6 the other person chooses.
And there's going to be a latency issue there too, because with I2P's TCP stack, everything in I2P is sent best effort, meaning that you send it and you hope it gets it. And with TCP, that's actually done in an application library where all the packets you're sending are sent best effort and received best effort, and because it's not totally optimized in the way that Tor's TCP is, where you basically have it's effectively done completely on bare bones C, whereas I2P is done with best effort stuff in Java.
I would say there's a slight difference there too if you're comparing to Tor. As far as Tor goes, there's 2 different methods that you can have in a network for sending packets. There's you can have packet switch networks and then circuit switch networks. Right. Circuit switch basically means you set up a pathway from you to your person you're talking to, and your packets that you send will always take that pathway. That's what Tor does. So your Tor client will choose 3 nodes, or guard, middle, and exit node, and your data for that particular circuit will always take that path. In I2P, it's each packet is evaluated individually. So you could have potentially different packets taking different routes all the time. Okay. The second point, as far as speed goes, is that
the latency
Tor has a very...
what I was going to say is that the latency in I2P has a very high variance. When you build a tunnel, you're not always with the current way things are situated, you're not always guaranteed you're going to have a very low latency tunnel, and it turns out you can have anywhere from 5-second latency for one tunnel to I don't know, 300 millisecond latency. So when you're doing stuff like TCP over I2P, that has a lot of baggage to carry, because you need to have your TCP stack be aware of the fact that you have this insanely, not insanely, but a really high deviation in latency.
Yeah, one packet could be delayed far more than another packet, and so
you can have one drop, or you could have one drop, or
yeah. So the benefit, of course, is that you can get much more variance in terms of the pathways that packets take, which is good from an anonymity perspective. But it's not as it has a corresponding detriment as far as speed goes, because you're not always taking the exact same path. And in Tor's case, that path is selected from a small group of 5,000 routers, relays that are all very very high bandwidth routers. In I2P's case, it's a full mixnet. You could be using any other router in the network, so you have more selection, but you're going to have more variance in terms of the speeds that you can get.
Right. In addition, Tor has the consensus, which allows them to really prune and tweak the not really the consensus, but what do they call it? Because they have that consensus, they're able to really optimize things in really ridiculously fine-tuned ways. Like, what was that one I read before? Anyways.
Oh, they can even they can tweak network parameters in every node in the network at will, because they can just say, they've written some code in the Tor client that goes, oh, I need to rely on this particular network parameter, and the client relies on that network parameter from the consensus. So the Tor devs can basically alter the entire operation of the network from those 9 relays. I2P has chosen to go the way that, because we don't trust ourselves, we basically don't trust ourselves with that power. Yeah. So every node has to make its own decisions, and we try and give them as good algorithms as possible to make those decisions. But at the end of the day, there's less that we can do with that.
Excellent. Okay. Yeah,
Of course, this sounds all very negative.
Well, no, that's
as far as
that's fine. I mean, you shouldn't, and that's a very pragmatic way of doing your security. I mean, decentralizing the management of it is quite effective for anonymity, because any one of you who would have access to your 9 servers could, they could be working for no such agency and upend the whole the whole reputation of the whole network, and people would still they wouldn't have any option after that. Yeah.
Well, it's like you take a step further, you go to a VPN. VPN, you're effectively trusting one server and one company, but you're going to get much better speeds than Tor. So it's that trade-off between privacy and security.
Yeah.
And that's one thing that I2P try. When you talked about earlier, you mentioned you could see that there's a lot of variables to tweak. One thing I2P lets you do, which I don't think is easy to do in Tor, is you can actually choose to build a tunnel that has less hops in it. So, which is beneficial. Say I'm Google and I decided I actually wanted to provide a hidden service to Google.com. So we'll ignore the slight irony in that situation, and go, okay, so what I could do is I could set up a server tunnel which only has 1 hop or 0 hops. So in a 0 hop tunnel, effectively, I advertise my own router as the endpoint to the tunnel. So other routers treat me as if I'm a tunnel, but it's actually just going straight to me. So what you do there is you immediately cut 6 other routers out of it, and you halve the latency and increase the speed you can deal with.
Sure.
So that's one example of where the server does not require anonymity, but they can still participate in I2P in order to give their clients benefits, in the same way that you could set up a hidden service in order to give Tor clients the ability to connect to it without having to go through an exit node.
Okay. So I'm looking at our show notes because I allowed Jeff and Strad there to get in on that. What is EAP sites? Did somebody just spell that wrong or something?
I believe that was meant to be in the beginning. I believe it was IIP, and it is. I believe it is a misspelling.
Okay, good.
Well, I put that, and that's how it's spelled on the I2P.net or GetI2P.net,
Yeah.
and that's what I thought. It was like IIP sites, but people just put it in quotes.
It's effectively a joke in a sense. From the the original devs 10 years ago, more who decided, what are we going to call these services? EAP sites, EAP services. Rather than, we spell them EEP, but we assume it just came because IIP, you can phonetically say that as EAP.
Sure.
But effectively, by EAP site, we just mean a website inside I2P.
Okay. So it's almost a direct analog to the hidden services in Tor.
Effectively, yes.
Okay. All right. So
Tor just uses hidden services as their more generic term for anything that they run inside Tor.
All right.
Whereas in our case, EAP sites was just more referring to websites.
Tor runs on Raspberry Pis. I have a brand new, actually, Raspberry Pi 2, the 1 gigabyte model. And I asked the question,
nice.
if you guys are, I got 3 of them actually. I was going to give them away, one of them away as a prize for on the podcast, but maybe later. So does I2P run on the Raspberry Pis?
We have a C++ port.
It does run. It does. Well, just before we get to that one, the Java one does run. We have a developer who specifically works on our packaging. He's basically our Debian contact, which we're slowly working on getting I2P packaged into the Debian repos. But he also does a fair bit of testing on Raspberry Pi, so the Java version does work. Okay. That said, Jeff?
Yes, we also have a in development C++ router that does work. Mm-hmm. You can get onto IRC with it. You can do all the things that almost all of the things you can do with the Java router, and it's really tiny. It's written in C++ by an individual using the name Original. He's from Russia, and he has spent quite a lot of time making the C++ router work and work really well. Cool. And it's actually better than the Java version on the Pi because it's got a much lower memory footprint and doesn't need the JVM to run.
Mm.
So.
Okay,
probably a lot faster too.
On those routers, is it like a TP-Link router or something that it runs on, or will it run on a?
It runs about the same memory footprint as a Tor client.
Okay.
And the main bottleneck is the crypto at that point because it has LGML. And the Pi just does not have the beef to like handle LGML cryptography. It just won't do it. Okay. Even with the Java router, it's a big bottleneck there. But as far as on the Pi, both the Java and the C++ routers work really. They're usable. You can get onto IRC and stuff.
Cool. All right.
The C++ one, of course, we should reiterate there are very likely still some
many
issues
bugs
with it. Many bugs because I2P's been around for 11 years, 12 years, whatever it is now, and the C++ one has only been developed over the last year, I believe, year and a half.
Yeah.
So it's still really very early stages. There's a lot of internal optimizations that are still being worked on, like peer selection algorithms, and like take for example the streaming library, which is the TCP implementation that I2P uses. Mm-hmm. It has a very basic implementation of streaming, enough that it can communicate with a Java router to run IRC or HTTP, but it's very minimal, and it's not going to be very useful for anything else at this point. Okay. So again, if there's a C or a C++ developer who's interested, we could also use you to work on the C++ router.
Awesome. Okay.
I love C++. Hey,
C++ is nice, yes.
I just thought of this on the way home today as I was thinking about things to say on the cast. You ever thought about having distributed websites? In other words, I want to publish a site on I2P, and kind of like the distributed hash table model, my site is distributed, so it's registered, kind of like the other I2P sites. But if my computer were to go down, it's still available, and that might be based on how much bandwidth I dedicate to I2P and that kind of thing, as to whether it be considered as a distributed site. You guys thought about that?
So there is actually an open bounty for that. Someone's put up, how many euros was it again? Like 2,000 euros for a data store bounty on I2P. The data store bounty for I2P. How much money has been put on that?
Well, it's sort of there. I thought some of it had actually already been claimed. But firstly, yes, distributed sites are certainly a big focus in I2P. Now, there's a bunch of different ways that you can do it. If you don't need anything interactive, and it can be literally, and in most cases for distributed sites, that's the case. You just have a static HTML website and you just put it up and it's there. There are several ways you can do it. Firstly is what we call multi-homing, which is where you have a particular destination or website in I2P, and you just run that tunnel from multiple routers. So then if one router goes down, there is still a tunnel up for it, and so you can effectively access it in multiple ways. That also helps to prevent correlation between when a router goes down and when a site goes down, which is beneficial for anonymity. The second way is using Tahoe Laughs, as I mentioned before, which is a distributed data store. It is a well-established means of storing effectively websites in Tahoe Laughs, so you can just store it in the distributed data store, and then anyone who's got the read URI for it can access the site.
So someone already claimed that bounty?
I'm just checking now. The third way, and this is actually something I came across a couple of days ago, Hello ZeroNet.
That one.
Yes, is a Twitter user for ZeroNet, which is a decentralized website using Bitcoin crypto and the BitTorrent network. That would be ripe for running over I2P as a decentralized web service system.
So if you could get someone to port that to use I2P, that'd be really neat.
Can you explain that one real quickly? I didn't catch all that. The third one.
So ZeroNet is effectively, from what I understand, a way to. It's like you use BitTorrent to upload your site, and it's served. It's like a web server served with BitTorrent, I believe.
Yeah. Okay.
Yeah. So effectively, the routers serving it are those who are interested in it, who share the network, and then the list of sites shared is stored in a blockchain.
And you have to solve part of the blockchain to actually get to the site, right? That's what I understood. Maybe I'm wrong.
I don't know.
So sure.
When you visit a new ZeroNet site, it tries to find peers using BT network, so you can download files. Each site becomes every visited site also is served by you. Every site contains site.json, which holds all other files in a SHA-512 hash and signature. If the site owner modifies the site, he or she signs the new JSON and publishes it to the peers. After the peers have verified the new integrity, they download the modified files and publish the content to other peers. Wow, that's fantastic.
That's awesome. I would love to see that.
We got to get that guy on.
Yeah, you should.
That would be very interesting to run over I2P. So it's something I've actually been meaning to do, is look into what BitTorrent library and blockchain type technology it uses, and how we would actually modify it, or even just in the simplest way wrap it effectively to run the connections over I2P.
Yeah. You guys need to get together. Kind of like, the Ghostbusters, what is the Keymaster and the Gatekeeper, right? You guys need to get together.
Yep.
Yeah.
Just back to that bounty, I just had a look. Yes, there is still the bounty up. It's about 150 euros and 2 BTC. The Bitcoin is actually far more than the euro worth at the moment. But basically, this was basically an idea to go back to a sort of a more freenet model, where the original idea of I2P, of course, was to be the transport freenet. This bounty was put up years ago for someone to effectively implement freenet on top of I2P. So having a general data store that you could put in chunks, and it would just be automatically everything would be replicated across. In a sense, that's kind of what we do with Tahoe now, but it's still not quite the same. So it is more oriented towards a freenet-like system. So if someone did want to implement a freenet-like system directly on top of I2P as a plugin or something that people could drop in and use, there's a bounty right there for it.
I really wish that the freenet people would just release all the specs they have, so I could take a month to spend rewriting it in C++. I really want that.
So
bad.
Freenet doesn't give out the documentation for their network, huh?
Well, I don't see any besides the reference implementation, which is the size of I2P's code base.
Yeah.
So it's really big. So
you have the same problems the OpenBSD developers have trying to get documentation for drivers and such. So I totally feel your pain there.
Yeah.
So.
Well, in a sense, we had the same problem with I2P for quite a long time.
And then we put a lot of effort in. So.
Yeah, there was at one point where I think it was IO Error actually mentioned at CCC one time or someone related to it was mentioned that they weren't particularly impressed by the fact that we didn't have much documentation. So they put aside development for 3 months and focused solely on getting documentation up, which is now what we have on the website. Not only that, but then things like the C++ implementation has been very good. Someone actually trying to use our documentation to implement a new implementation of the router has been able to help bug test our... Still needs work, yes, of course, but that's been very beneficial in terms of documenting what's actually going on with the I2P protocol to make it easier for people to implement in another language if they want to.
Now, I must say that when I installed I2P, it was pretty dang easy. I did it on Debian. I, just downloaded the packages, followed the instructions. And the only issue I had was, what is this 32-bit address? And I found a text file with a bunch of people's addresses on it. They were 512 addresses. I couldn't get those in the URL, and I didn't know how to use those, and I didn't see any documentation on. That's the only stumbling block I had. But as far as installing it, using chat, building the site, I looked up torrents to download the InfoSec Daily podcast. All that was pretty straightforward for me.
Yeah, I didn't have any problem setting up I2P. It was pretty freaking easy, and I didn't have to use any instructions. I used the instructions that Boettcher gave me, and we were good to go.
Yeah.
Nice.
Yeah.
Well, that B32 is what it is. That here is actually... Yeah. So when I talked before about at least it being stored in the network database, the hash it's stored in is that 50-character hash that you saw, the .b32. Mm-hmm. So an I2P destination itself is generally about 516-ish character
well, it's variable at this point. So.
At this point, it's variable. But basically what that includes is an encryption key and a signing key. The encryption key isn't actually used anymore, but that there is effectively the public key of the service. We then take effectively the SHA-256 hash of it, and that gives us a, whatever it is, 52-character string, which is effectively a unique identifier for accessing a service. That can be used in your browser to access an EAP site directly. It can be used... torrent clients can use it. That's what they use to refer to other nodes. It's just a general way of accessing it that is in a format that looks like a domain name. So it's easy to use within systems that expect to see a domain name.
With a dot and all that stuff, yeah. So going back to the documentation part, I found that the documentation is sufficient enough to build a re-implementation. It's just that it's not always straightforward because documentation isn't quite complete yet. And to get a full view of what the documentation is saying, you need to be on IRC just in case you come across something that doesn't really sound like, is this really right? Yes, that's right. So in my experience rewriting the Python API, writing the Python API for I2P, there's been a lot of cases where I've asked, is this right? Yes, that's right. And it's really, you have to go back and forth with the documentation to make sure it's right. So,
sure.
Yeah.
Okay.
Because it's still kind of spotty in some places. So
the Breaking Down Security podcast is on Facebook. Our fan page is facebook.com/Breaking Down Sec. That's BRAKEING down SEC. Yes, on LinkedIn, we do spell it with my last name, ING. It is not a misspell. So, yep. Thank you again, Jeff and Strad. Y'all need to go get some sleep because if Strad's accent is any indication, it's really, really early where he is. And Jeff, go get some sleep, brother, and decaffeinate. And this has been an awesome podcast. I've learned a lot here. So if you guys ever want to come back on, if you've got something you want to discuss, on the down low, please feel free to come back. We'd enjoy it.
Sure thing.
Well, now I've figured out my setup. It's going to be much easier next time.
Yeah. Well, just restore from Snapshot and get rid of Skype, and you'll be good to go. So,
yeah.
How about you, Mr. Boettcher? You got anything else?
No.
Cool. All right, sir. This has been Breaking Down Security. Everyone have a good week, and we'll see you soon.
Bye-bye.
See ya.